Next, we're going to talk about section 2.7, which is about combining functions. So first, we're going to discuss algebra of functions. So basically, in the first part, we're going to talk about given two functions, function f and function g. Remember, for each input x, if you throw it into machine f or function f, it gives me exactly one output y, which is f of x. For each input x into function g, it gives me exactly one output of x. Now, what if I want to create a new machine or new function f plus g? How do I want to define this? Well, mathematicians decided to define it this way. For each input x into this new function, you get an output f plus g of x, which follows the pattern. But what is f plus g of x? It's the output you got from f and the output you got from g, and then you add them together. Okay, so to do f plus g of x, you just simply do f of x plus, it's like distributing the x, but it's not distributing. And if it was f minus g of x, again, common sense says it's f of x minus g of x, f times g of x, f of x times g of x, f over g of x, it's f of x over g of x, as long as you don't divide by 0, okay? Now, to find the domain, what's acceptable into this new machine? What can we throw in? Can we throw in negatives? Can we throw in 0? Well, in order to be accepted by f plus g, it has to be accepted by f, and it has to be accepted by g. So the domain of f plus g, domain of f plus g, f minus g, f times g is all real numbers that are in both domains of f and g. Whatever is acceptable by f and it has to be acceptable by g, then it's going to be acceptable by f plus g, f minus g, f times g. Now I left out f over g because f over g has one more restriction. Domain of f over g, it's all this, and remove from that domain any x where g of x equals 0, because the denominator cannot be 0. So if g of x equals 0, 1 equal 2, you remove that from the domain of f over g. Okay, that's what this is about. So, and there's a handout for all these rules. It's again in that notes about combination of functions. It lists all the rules, domains, and then we talk about composite functions, and then examples. There's 2 pages. It's all included in your notes. Okay, so let's see an example about this. Let f of x equals x squared plus 2x, and g of x equals square root of x squared minus 1. Find. The first thing that we will do is f plus g of x. Well, by definition, this is f of x plus g of x. F of x is x squared plus 2x. G of x is square root of x squared minus 1. We don't have any numbers to plug in. We got an equation for f plus g, just like we have one for f, just like we have one for g. Okay, f minus g of x. Again, by definition, it's f of x minus g of x, which is x squared plus 2x minus square root of x squared minus 1. Again, we got an equation for f minus g, just like we have one for f plus g. F times g of x. It's f of x times g of x. X squared plus 2x times square root of x squared minus 1. So we got an equation for f times g. And finally, we want an equation for f over g, which by definition f is the numerator, so it stays there. So it's x squared plus 2x over square root of x squared minus 1. And they want the domain of all these functions. All these three will always have the same domain, okay? So the domain, so in order to find the domain of these three, we're going to find domain of f and domain of g. What's the domain of f? Again, any x I plug in, 0, -1, -2, 10, 5, any positive, any negative, and 0, I can plug it in and get a y value, so it's all real numbers. Domain of g, well, square x minus 1, x squared minus 1, that has to be greater or equal to 0. And if you work it out, remember you do x squared minus 1 equals 0, you get the critical values, and then you do your chart, quadratic inequality, and you do -infinity to -1, -1 to 1, 1 to infinity, and you check one value in there. If you put a 0 in there, it's going to be -1, it's false. If you put a -2, that's true. That's true. So the domain is going to be -infinity, -1, union 1, infinity. So domain of f is all real numbers. Domain of g is this, where they overlap, because it has to be in both, so they overlap at this. So the domain of f plus g, f minus g, and f times g is -infinity to -1, which means we can pick any value from this interval or that interval and plug it into f plus g, f minus g, f times g, and get a y value. If we pick a value between -1 and 1, like 0, it's not going to work. Why? Because if you put a 0, look, in f plus g, square root of 0 minus 1, that's imaginary, okay? That's what this is about. Now, so we did the first three. What about domain of f over g? Now, it's going to be all this. Remember, it's all this. That was for f plus g, f times g, and f minus g, except where g equals 0. Except where g, which is what's g of x equal to? Square root of -1 equals 0. That equals 0 when x squared minus 1 equals 0, when x equals plus or minus 1. So we're going to remove the endpoints. So it's going to be -infinity, -1 with parentheses, union 1, infinity with parentheses. Because these cannot be plugged into f over g, because if you do plug them into f over g, it's going to be undefined. There we go. If you put a 1 there, look what's going to happen at the bottom. 1 squared minus 1 is 0. Any number over 0 is undefined. Okay, let's look at page 216, number 16. Page 216, number 16. We have f of x equals 2 over x plus 1. G of x equals x over x plus 1. Find the same thing, f plus g of x. It's f of x plus g of x, which equals 2 over x plus 1 plus x over x plus 1, which is 2 plus x over x plus 1. Now the beauty of this, that's not part of the question. Now if I want to do f plus g of 2, I don't have to do f of 2 plus g of 2 anymore, although I could just plug it in there, so it would be 2 plus 2 over 2 plus 1, which is 4. So we have an equation that we can use for f plus g, just like any other function. F minus g of x, it's f of x minus g of x, 2 over x plus 1 minus x over x plus 1, 2 minus x over x plus 1. That's f minus g of x. Okay, then we're going to do f times g of x, which is f of x times g of x, 2 over x plus 1 times x over x plus 1, which is 2x over the quantity x plus 1 squared. Okay, and then finally f over g of x. It's f of x divided by g of x, which is 2 over x plus 1 divided by x over x plus 1, which is timesing by the reciprocal, which is 2 over x. Alright, now the domain of f, let's see. Domain of f is all real numbers except -1. So it's negative infinity, -1, union -1, infinity. Domain of g, same thing. So they overlap at the same. So domain of f plus g, f minus g, and f times g is all this, except -1. All real numbers except -1. For domain of f over g, again, we want to make sure that g does not equal 0. And g does not equal 0 when x does not equal -1. So if you look at f over g of x, if you look at f over g of x, you can plug in any number here except 0, and you cannot plug in -1 because of the domain of g. So we're going to do negative infinity, -1, -1, 0, and then 0 to infinity. You can't have -1 because of this, and you can't have 0, right, because of that. So, okay. So these are 4 new functions. The next new function is called composite functions or compositional functions. So now if we take f and put it next to g and we input x into f, we get an f of x. Instead of inputting x again into g, we're going to take the output from f and make it as an input in g, and we get g of f of x. G of f of x, which we actually write as g composite f of x. Which means you're inputting f of x into g. As you can see, we're inputting f of x into g. So we always input the closer letter to x into the outer letter. So we input f of x into g, okay? If we reverse f and g, we do g, then f, input x into g, we get g of x as an output. We take that and input it into f, we get f of g of x, f of g of x, which is f composite g of x. Again, here we're inputting g of x, the closer one, into the outer one, into f, okay, the equation of f. So, and these are not necessarily the same. F composite g and g composite f are not necessarily the same. And if you look at the domain, I'm not going to write it down, it's in the notes, but let me explain. So if you're looking at the first one, domain of f or g composite f, x has to be in the domain of f, and right, x has to be in the domain of f of x has to be in the domain of g. Two components. X has to be in the domain of f, and before it was x has to be in the domain of g. Now it's not. It's x in the domain of f and f in the domain of g. If you look at the other one, x has to be in the domain of g and g has to be in the domain of f. X has to be in the domain of g and g has to be in the domain of f. What about that? Okay. All right. So if we look at this example, f of x equals 3x minus 5 and g of x equals 2 minus x squared. Just a warm-up example. Find part A, f, composite f of -1. So we're inputting -1 into f, and then we're inputting f -1 into f again, no g. So this is basically f of -1. So we're going to start with the inner function, f of -1. Yeah. Okay. So if we find f of -1 right there, that's 3 times -1 minus 5. -3 minus 5 is -8. So that's -8, and then we're inputting this into f again. So it'll be 3 times -8 minus 5, -29. So f, composite f of -1 is -29. Let's try g, composite g of, again, this is g of 2, inputting that g again. But we're going to do g of 2 first. So right there we do g of 2. It's 2 minus 2 squared, which is 2 minus 4, which is -2. So we take that and put it in there. So it'll be g of -2. We input that in there. 2 minus -2 squared, which is 2 minus 4, which is -2. So g, composite g of 2 is -2. I'm going to do one more. So part C, f, composite g of -2. So we're going to do the closer one first, g of -2, and then we're going to input that into f. If we do g of -2 right here, we get 2 minus -2 squared. 2 minus 4 is -2. Now this -2 is going to be inputted into f. So right there, f -2 is 3 times -2 minus 5. -6 minus 5 is -11. Okay, so you always start with the inner function, the closer function to the number. And you get the answer, and then you plug it into the outer function. Alright, number 36, page 217. They want you to look at the graph, page 217, number 36. Page 217, number 36. It says find f composite g of 0 using the graph. So you're going to do a g of 0 and f of that. If you look at the graph, it's the blue one. G of 0 is 3. You need to be looking at the graph, and then you're going to do f of 3. 3 is on the red graph, of 3 is 0. So the answer is 0 for f composite g of 0. Alright, number 50, page 217. 50, page 217. It says find f composite g, g composite f, f composite f, and g composite g. So we're given f of x equals q plus 2, g of x equals cube root of x. Find f composite g of x. So there's no number to plug in. Okay, we're trying to get the agent for f composite g. We know we're going to do this first, so it's f of g of x. So we're going to plug g of x into f, but g of x is cube root of x. So we're going to plug cube root of x, g of x is cube root of x. We're going to plug it into f right there. So we're going to remove x and put whatever inside the parentheses in for x. So it's cube root of x cubed plus 2, which is x plus 2. F composite g of x. So we plugged g of x, which is cube root of x, into f. To plug this into f, we put it in for x, cube root of x cubed. It cancels out, and then you get x plus 2. Now if you want to do g composite f of x, so it's g of f of x. This time we're gonna input f of x into g, but f of x is all that guy, x cubed plus 2. We're gonna input this for x, so we're gonna be cube root, instead of x, it's gonna be x cubed plus. And then we're gonna do f composite f of x. F composite f of x. So we're going to input f of x into f again. F of x is x cubed plus 2. We're going to take this and put it in for x into f, right? Not x, no g here. So x cubed plus 2, it's going to be cubed, right? X cubed plus 2 is going to be cubed and then plus 2. F composite f of x. And finally, g composite g of x. So we're going to input g of x into g. G of x is cube root of x. But we're going to input this into g. So we're going to put cube root of x in there for x. So it's going to be cube root and then cube root again of x. Okay. And it says find their domains. Oh, we didn't talk about their domains. Hold on. So if you look at domain of f, you can see you can put in any negative, positive, or zero. So domain of f is all real numbers. This is also all real numbers. So for f composite g, it has to be in the domain of g, which is all real numbers, and this has to be in the domain of f, which is all real numbers. So all of them are going to be real numbers here. No, because it's all real numbers. Now 50, I did 50. Now 56, it's done in the notes, but it's you to work on right now, okay, or after I'm done. But I want you to do 56, page 217, a good place. And it's solved in the notes, okay? So now number 60. Page 217. We have f of x equals 1 over x. G of x equals x cubed. H of x is x squared plus 2. We're given all these functions. It says find f composite g composite h of x. Well, we're going to follow the same procedure for 2. It applies for 3. We're starting with the inner function. So it's h of x, and then g of that, and then h of that. I'm sorry, f of that. Okay, f of g of h of that. So start from h of x, which is x squared plus 2. We're going to plug it into g. And then whatever we get, we plug it into f, one step at a time. H of x, which is x squared plus 2, it's going to be plugged into g, and then whatever we get, it's going to be plugged into f. So what we take x squared plus 2 and plugged it into g, so we cube it, x squared plus 2 cubed, and then we're going to plug this into equation of f. All what's going to do is do the reciprocal, so 1 over x squared plus 2 cubed. And that would be the answer. Now number 68, page 217. 68, page 217. It gives us a combination of function h of x square root of 1 plus square root of x. And it has a function as a composition, express the function in the form f composite g. So if you want to write this as f composite g, which one is going to be f and which one is going to be g? Well, the inner function is going to be g's. This is the inner function, so you let g of x is root x, and then f of x is going to be root 1 plus x, right? Because you plug g in there, so it's going to give you that. Alright, 80 is the last one that I want to do. Page 218, that's a good example about composite functions with shocking. It says you have a $50 coupon from the manufacturer that's good to purchase of a cell phone. The store where you're purchasing your cell phone is offering 20% discount on all cell phones. Let X represent the regular price of the cell phone. Regular price of the cell phone. So you have $50 coupon and 20% off. Suppose only the 20% discount applies. Find a function f that models the purchase price of the cell phone as a function of the regular price. So if it's percent off, so f of x, the purchase price, if you're doing 20% off, you're paying what? 80% of x, right? You're paying 80%. 20% off, that doesn't mean you're paying 20%, you're paying 80% because the regular price is percent. So that's gonna show you the price after doing the 20% off. And part B, suppose only the $50 coupons apply. Find a function g that models the purchase price. So if it's $50 off, so it's x minus 50, that's gonna be your purchase price. And part C, if you can use the coupon and discount, then the purchase price is either f composite g or g composite f, depending on the order. Well, if you do f composite g of x, it's f of g of x, which means you're doing the $50 off first, and then you're doing the 20% off, so it's 0.80 times x minus 50, which is 0.80 x minus 40. That would be your final price. That's if you're doing the $50 coupon and the 20% off. If you do the other way around, you do g composite f of x, that means you're doing f of x first, which is the 20% off, and then you plug it into g to get the minus 50, and this is g composite f. So which one would be better? Of course, you are better off doing g composite f, right? Because you're going to be paying less, taking 80% minus $40 here, and then you're taking here 80% minus $50. Okay, so this would be better off for you. So be a good shopper. All right, and that ends 2.7. It was a bit long, but we made it.